a y squared or just an x squared. Remember, guys, you have your calculators that have all the standard forms on these things. The only one conic that has only an x squared term or a y squared term is the parabola. This is a parabola, okay, because it's got a y squared term. So when I look at my setup, I know it's going to be a y squared parabola because it says y squared. That means if you look at the formula, the only thing that's going to be on one side is the y stuff. Everything else goes to the right. So I'm going to keep just the y squared stuff. Y squared minus 12y blank. So I'm going to have to complete the square. Equals negative 4x minus 4. Completing the square. Make sure that your a value is positive, or excuse me, a value is 1, which it is. And I take half of b. What's half of negative 12? Square it. I'm adding 36 to both sides. That meant that my term was the half of b. But I'm not done. The generic formula for the parabola has y or x minus something in parentheses, which means I need to factor out the negative 4 to get an h value. Now I have my equation. That's all I asked you guys to do over the weekend, and this is where it's going to change up now. What we're going to do for what you have on here is that you're going to add all of your graphs as well as the parts that you need to be able to label. Okay? This is a parabola. We know where the center is. We can find everything else now. The center, your HK, is at 8, 6. So I go to plot. Eight, 6. It's got a negative 4, so is this opening left or is this opening right? Left. Opening left. Now we got to figure out our p-value so we can figure out where our focus goes. Negative 4 equals your 4p. What's p? Negative 1. So that means that my focus is at the ordered pair 7, 6. Okay? It's opening this way. And what's the other thing that we have to label on a parabola? The directrix. You're close. The directrix is one more. And that's what you would have to label out. For parabolas, you got to label out the center, the focus, and the directrix. That's it. Great. Oh, you just said that. You just said it a second ago. This is the next step to what you were doing. You can zone back out now. Wait, you had homework? I'm just messing with you guys. Sure. All right, now we're looking at the next one. We have an x squared and a y squared, which means it's going to be either a circle, ellipse, or a hyperbola. One of those you can probably get rid of right away. Which one can you, well, I already said it's not a parabola. What's the other one you can get rid of? I can get rid of the hyperbola. Why?
Because there's a plus sign.
Because there's a plus sign, yeah.
Oh.
That's one of the big giveaways to tell whether or not you're going to have a circle or an ellipse versus a hyperbola. Between the x squared and the y squared, if it's positive, it's either going to be a circle or an ellipse. So we set this up. Again, when we're doing these, group your x squareds together, your y squareds together. And move the constant. Again, for completing the square of this problem, I don't have to really worry about any of the leading term coefficients for a. So all I have to do is just take half of b's and square it. So what's half of negative 6? This would be negative 3 here. Add 9 here. Add 9 here. Half of negative 8. So remember, the half of b goes there. Add it, square it, and add it to both sides. Is it an ellipse or is it a circle?
Ellipse.
It's a circle.
Circle.
Correct. Well, it is over a and b, but what are a and b? They're both 1. They're the same value. The reason that this is going to be a circle, since the a squared and the b squared terms are the same, it means it's a circle. They could have been both over 4. Could have been both over 12, whatever. If those two are the same, then it's a circle. Okay? Or if you don't see it over anything, it's just equal to 1 or equal to 12 or whatever, that gives you your radius. So here's what happens when we go to graph our circle. When you go to graph a circle, obviously your center is at 3, 4 for your HK. And you guys graphed these the other day. They're really easy. We just walk our radius. What's the radius? 1. So my radius goes up 1, right 1, left 1, down 1. And I just label out all 4 of those points. So do 4, 4, 2, 4, 3, 5, and 3, 3.
So the radius is something, the square root of something important?
Wait, this one's wrong.
Yeah.
4, 4. Yeah, I was right. 4, 4, 2, 4, 3, 5. Yeah, I'm right. Just thought I was wrong. You add 1, correct 1. Again, what you're looking at here doing, guys, is that labeling out your 4 points. Okay. Now, if it was, let's say it was the square root of 6 was your radius. If it was the square root of 6, and you had to move it up 1, it would be 3 comma 4 plus root 6, 3 comma 4 minus root 6, and so on. You just move your roots if you had to. You don't have to give the decimal values. You don't have to do any of that. And I have an example of that with the ellipse or something, I think, coming up here real soon. Right. Just so you guys know how that works. So graphing the parabola and graphing the circle are the 2 easy ones because you've done them many, many, many times. There's not a lot of extra parts you have to really worry about. When it gets down to working with the other ones, that's when things can get messy. You have to be very careful what you're labeling out. So, let's look at it. We got 53. You ever seen one of those? Children's Museum, I think out in Rockford, they've got one of those where it's basically just 2 parabolas, or not ellipses right across from one another, where the other person can hear you clearly. The way that the arc goes on. It's so cool. It really is.
Yeah, so like, let's say.
What do you mean? No, that's because it listens. You hear it picks up the vibration in the string. Yeah, if you use a tin, like a metal can, you tie it up right.
And the string needs to be
Yeah, there can be a slap in it. In this case here, oh Willis. Yeah, it's going to wind up being a hyperbola. You can kind of tell that right away because between the x squared and the y squared, there's a subtraction symbol. So we know it's going to wind up being a hyperbola in the end. So let's start moving things around. Again, I'm going to group my x terms together, my y terms together, move my constant over to the other side. So I have 9x squared plus minus 72x minus y squared plus 8y equals negative 119. Now, in order for me to be able to complete the square, I need to first get rid of that a value, that 9. So I'm going to factor out the 9. Factor out the negative 1. Now, I factored out a 9 and I factored out a negative 1. What do I have to put on the other side? You got to put them back in. That's usually what people forget. Okay. Again, what's half of negative 8? 4. Square it. Winds up being the both for both of these. I'm just going to add 16 in right away for both of them. And over here. So I have 9x minus 4 quantity squared minus 1 y minus 4 quantity squared equals use a calculator.
I don't. That's why I got really mad at the beginning because I was like telling myself to remember to bring my calculator the entire day, and then I got distracted by something.
Now what do you do? Very good. So you divide everything by 9. And you're right. We're at a hyperbola. You don't have to. I do because that way it's easy for me to label out A's and B's here in a minute. So at this point, where you know for certain we're at a hyperbola. So what I'm going to do, look at my equation for the hyperbola in the calculator. I'm sorry, what was that? It's fine. Still don't get ordered pairs. No? Yeah, there's no, I mean, it's great you get an idea of where everything can be placed around, but there's no need. So, no problem. So here's what we do. Which one came first, x squared or y squared? The x squared. So that means I know it's going to be the top one. It's moving left and right. So what I do now is I'm going to go ahead and graph this. When you graph the hyperbola, there is a lot of stuff you have to be able to identify. First thing you identify is center. We got to do vertex, the co-vertex, the focus, and then we have to do the equation of the asymptotes. There's a lot going on. So we start out with the center. Center was at what? 4, 4? Center's at 4, 4. I'm looking at this. What is my a squared value? 1. My a squared is at 1. So a is plus or minus 1. B squared is 9, so b is plus or minus 3. C squared is going to equal how much? Hold on here. It's going to be 10. Remember, the reason we can tell the a squared and b squared if it's an addition or subtraction for it, it's the opposite of the sign of the graph you're looking at. We're having a hyperbola that's got a subtraction sign, so that means the a squared will be plus b squared. When you have the ellipse, it's vice versa. So our c squared here is going to wind up being 10. So c is going to be plus or minus root 10. So A always stands for the distance from the center to the vertex. It's moving left and right, so all I have to do is go right one and left one. So my vertex are at 5, 4, 3, 4. Co-vertex, use that to find B. Plus or minus 3. So at 4, 7, and 4, 1. Correct. Draw your rectangle. Okay. our focus. Our focus is the distance from the center, you use C. I really can't add the square root of 10 to 4 very well. But am I adding it to the x value or the y value for the center? The x value, because it's moving left and right. So my focus ordered pairs will be at 4 plus root 10, comma 4, and 4 minus root 10, comma 4. When I look at that graphically, the square root of 10 is a little bit more than 3. About here-ish. Okay? Just putting it on the graph. I labeled the ordered pair correctly. I ished it a little bit on the graph then. It's close-ish. Asymptotes. Put in the asymptotes, those are your diagonals. Now, you have two ways of writing up for the asymptotes. It's either going to be A over B or B over A. Which one is this? B over A. So your slope is plus or minus B over A in this case, so it's going to be 3, plus or minus 3.
How do we know it's B over A?
When it's left and right, it's B over A. When it's right, left, it's A over B. Or up and down, it's A over B. I'm sorry, what's that? What did I say? Oh, I meant up and down. Sorry about that. Okay. I didn't even realize I said that. Oh well. Now, when this was centered at the origin, we just said it was just plus or minus 3x. It's not centered at the origin anymore, which means I have to write the equation of the line that has the slope 3 or a slope negative 3. What point do I use? The center. It goes through the center, so you're going to use point slope form twice. Here's your slope. You use it once with 3 and once with negative 3. So it'll be y minus 4. Like I said, there's a lot you have to do on a hyperbola. You're writing the equations of the slant asymptotes. 3x minus 12, add 4, you get 3x minus 8. Here we get negative 3x plus 12 plus 4 plus 16. Oop, didn't make my curve. So when we take the test on Friday, remember test is on Friday, when I ask you guys to write out the equation in the standard form graph and label all parts, I'll have a place I'll write on there vertex, covertex, focus, if needed equation of the slant asymptote. Right? Because you only need to do the slant asymptote equation when you have a hyperbola. Yes, ma'am? If it goes through 0, then it would just mean whatever the slope is times x. We did that before. We wrote out the asymptote as plus or minus 3x. I made this clear again. Test is Friday, right? Sure. I think the next one is the ellipse then. We will have one of each. All right. Again, the first thing I'm going to do here is I'm going to combine my x's together, my y's together. Mike, get him in the back. Is there any reason why you're trying to drown yourself? Are you having a bad day? You know, days get better. It can't rain all the time.
Squeeze his cheeks.
Oh, you love water?
Yeah.
We're gonna call you Chico de Nadar. Who does what? Is that what you two are doing? Jeez. Hey, you know what? At least he's being quiet and taking good notes. Or he's about to write us a thing. He's writing about us a note. There's a lot of dead airspace right now in the recording. I apologize for those that are listening to this right now. Yeah. All right, let's move things around.
Jeopardy.
I'm not looking right now.
Got it.
You're listening. Yeah. It says Casey. Spelling's not your forte. It's okay. You should just step on your foot. Anyway, take the 4 out. You want to repeat that for the rest of us?
I'm good.
You know, I can still read lips, right? All right, anyway, what's half of negative 12?
I don't know.
Remember, guys, take half of b, square it, and add it to both sides. So half of b is negative 6. That's my term. 36 goes over here. Here is just a 1. This b, half of that is negative 2. Square it, you're adding 4. And what's 48 plus 4 times 36? That's 100, I believe.
Yeah.
Divide everything by 100. And we have x minus 6 quantity squared over 25 plus y minus 2 quantity squared over the 100 equals 1. And again, this is obviously an ellipse. We just need to figure out if it's stretched up and down or stretched left and right. So we look at our calculator. With the ellipse, what's the rule with the a squareds and the b squareds? Willis? Or Derek? Whichever one's bigger goes where? Huh? Yes, yes. Whichever one's bigger is the a squared. Okay? So a squared in this case is going to be the 100. So is this going left and right or up and down? This is an up and down one. Okay. So your center is at 6, 2 for your h and k. A squared is 100. So A is plus or minus 10. B squared is 25, so B is plus or minus 5. What will C be? Or excuse me, C squared? Yeah, it's minus. It's minus this time.
It's plus or so it's oh, it's just minus. Plus or minus.
Very good. It's 5 and 3. So right there we've labeled out all the important stuff to be able to graph. Go to graph this, start at 6,2. There's your center. From there, your A value is always the distance from the center to the vertex. So I go up 10, down 10. So my vertex, co-vertex, and focus. Move this up a little bit. If I'm moving up 10 from the center, what am I adding to, the x value or the y value? The y value. So my vertex will be at 6, 12, and 6, negative 8. Add 10 to 2, subtract 10 from 2. All right. The B value is always the distance from the center to the co-vertex. Now I'm moving it left and right, so just adding that to the x coordinate, and I'm going to add plus or minus 5 to it. So it'll be at 11, 2, and 1, 2. Excuse me. It was a cough, but thank you.
So something that left
Thank you. Focus. Remember, the focus is always going to be inside the curve. The curves always look at the focus. In this case, it's the C value, that square root of 75. The square root of 75 was more than the square root of 64, but less than the square root of 81. So it's 8-ish. So I'm just going to add 8-ish. So about 10 something. And so I know they're both going to be right there and there. But when I go to label my ordered pair, am I adding that focus value to the x or to the y coordinate? To the y, because it's up and down. Okay. So your focus will be at 6, and it'll be 2 plus 5 root 3, and 6, 2 minus 5 root 3. That's how you, I think you got revolved water in that case. That's so gross. And again, at this point here, do I have to worry about any estimates of it? So girls, is this like the coolest thing to get them a date or what? No. Tickle them. Again, I gave you guys 4 examples of what the next step is for these. I'm going to let you guys have the rest of the class period to finish out the rest of your problems from over the weekend. You should have already gotten them into standard form. It's just a matter of graphing them now. Is there any one of the ones that you had that you want to double check if you got it into standard form correctly? And then go from there. Again, does it make sense what I'm asking you to do by listing out your ordered pairs and all that kind of fun stuff? Doesn't want to work. Whatever. I guess it did work. All right, group them together. 16x squared minus y squared plus 16y is 128. The one on the left here, that just means that there's no, when I go to complete the square, I don't have to. Because that means the h value would be 0. So this is just 16 times x minus 0 quantity squared. You can split it out like that if you have to. Sometimes it's easier to see. On the other part, I subtract, or take out the 1, and I have y squared minus 16y blank. So this will equal 128 minus 1 times something. Half of it, negative 4 squared, and bring it over. Thank you. So I have 16 x minus 0 quantity squared minus 1 y minus 8 quantity squared equals 64. It's going to be a hyperbola, but I'm going to divide everything out by 64. Well, x squared over, is it 4? Yeah, over 4, that's fine. Minus y minus 8 quantity squared over 64 equals 1. And then from there you can go about it. Okay? We okie dokie? All right, you got the time? Go ahead and keep going. We'll check these out tomorrow. After that, we're going to go, tomorrow we will start with the systems of these. It's relatively straightforward.
You want us to just graph it back?
Yeah, graph out the rest of them, but remember, list out your ordered pairs as far as the focus, your centers, your covert, your text. Label out what the equations of the sign asymptotes are if you have to. Those are only with the hyperbola. Okay? Whatever ones you have left to do. Oh, there'll be systems of conics. Yes, sir. No, that's fine. Yeah. Yeah, you start basically at this one. Yeah.
What you done, there's only 2 questions.